Hi everybody. Today we are going to discuss about the embedded system design. In this, the I/O devices and the types of example of I/O devices we can discuss one by one. The embedded system means we can embed it into a single system. It is called as embedded system mainly. The many peripherals is embedded or inbuilt or combined in a single device. It is called as embedded systems. Suppose we take a best example of embedded systems, our mobile phone or our washing machine is the best example for the embedded system. Why it is embedded system in the sense it's containing the memory unit, power unit, antenna and storage unit, input unit, output, everything is there. So it is embedded into a single device that it may be a mobile phone or refrigerator or washing machine, whatever it may be. So embedded in a single system, it is called as embedded system. That the I/O devices plays a major role for every devices, but especially the embedded system, it's major role. So I/O organization mainly the computer system, input output system having the interface the outside world. So mainly the architecture is interconnect or interface to the outside world. That is called as I/O system. We have discussed the two important models of the computer system, mainly the processor and also memory module. So this two is very important. The third key component of the computer system is very important one is the I/O module. Because without processor it won't work, without memory it won't work. Likewise, the I/O module also is a major role. Each I/O module having the bus and controls. One or more these devices may be controlled. So this is the main parameter of the introduction about the I/O systems. Mainly, the programmed I/O, interrupt-driven I/O, and a direct memory access (DMA). These are three important basic parameters of the input I/O systems. Mainly, the programmed I/O having the direct control of the I/O operations, including the sensing devices, sending the data, and read and write operation. Everything will be called comes under the programmed I/O. And the interrupt-driven I/O in the sense it's having the processor issues an I/O commander, the continuous to expect the other instructions, mainly the module when the I/O module is complete its works, the main interrupts of the driven I/O. And DMA, that is a direct memory access. You have the I/O module, the main memory exchange the data directly without any external involvement. It is called as a direct memory access. And next one is a problem with the programmed I/O is mainly having the solution with the interrupt mechanisms. So mainly the CPU and the other parameters available to polling that the CPU polls as available for the cable to accept the data. That is called as a polling to identify the information. This is the main interrupt driven of the I/O devices. So mainly the direct memory access DME having the two different approaches, namely a programmed I/O, interrupt driven I/O. So both or method requiring the active intervention of the processor is needed in between these I/O modules and the memory. So transfer must transverse the path through the processor, mainly having the I/O suffer the backdrop drawbacks is nothing but the I/O transfer rate is limited in the speed in which the processor can test the device of the service devices. And third one is the processor is titled upon the managing on the I/O transfer, that is input output transfer, the number of characters and must be executed of each transfer. And mainly the buses is also plays a major role, like with the I/O port. The processor, main memory and other I/O devices interrupt through the common bus or common devices, nothing but a common buses. The primary function of the bus is nothing but provide the communication path device and transferring the data. The buses include the control lines needed to support the interrupts and arbitrations. And mainly the buses lines used to transfer in the data group is the three categories: the data, address and the control line. These three important parameters useful for the buses and bus communications. Mainly the read and write operation, that is a line having the read and write operation. And a byte word, a long word or control signal is used for the size of data. And a bus controller is carrying the information from one part to another part or one place to another place. This is the control lines. The memory write, memory read, IO write, IO read. So transfer acknowledgement, bus request, and the bus grant. These are the clock resets. These are all the control lines of the IO devices mainly. Without this thing, the control line won't work. So device also it will be work with the help of the IO devices. Mainly the external memory having the non-Newman stored programs principle is used in the managing of main. And mainly the semiconductor devices used in the natural gas volatile memory, and also the permanent storage information and the non-volatile memory. We see some information is a non-volatile memory, and also mainly the storage purpose we are using in terms of external memory. So we have the magnetic devices like a magnetic disk, hard disk, floppy disk, magnetic tab, pen drive, and all. The optical devices like a CD-ROM, DVD-ROM, and etc. comes under the optical devices of the storage memory. These are only some important parameters that is performance of the devices. Thank you.